Notice on your calendar you have a quiz tomorrow that will be over the radian measures of the special angles on the unit circle. So make sure that you know all those radian measures and where they go on the unit circle so you can do well on your quiz tomorrow. It will be short and sweet. All right, so on your notes, this is going to go on page 88 when we're done. So we looked at the trig functions for specific special angles on the unit circle yesterday. We are going to talk about the unit circle and how to learn it, but I wanted to do that in person, so we'll talk a little bit more about it tomorrow. Today we're going to look at trig functions for any angle, not just the special ones that are on the circle. So this says let theta be an angle in standard form. So that means that the vertex, standard form means that the vertex is at the center of the circle, one ray is on the positive x-axis, and the point P, which is xy, is going to be a point on the terminal side of theta, so point. And distance from P to the origin is r, so basically the radius of a circle. It's not necessarily 1, not necessarily the unit circle. And so it can be found using which it gives it away right there, the Pythagorean theorem. But if this is my little triangle here and this point is xy, remember this is my x value, this is my y value. So legs of a right triangle, find a missing side, it is the Pythagorean theorem, so it looks like this: x squared plus, that's not plus y squared equals r squared. There's your Pythagorean theorem version of what's happening with your lengths on the coordinate plane there. So sine of theta, now we came up with this yesterday on the unit circle. We know that sine of theta equals y, that's what we put for the unit circle. That's when the radius was 1. Before we got there, since the radius wasn't always 1, it's opposite over hypotenuse, it's y over r. Y over r is sine of theta. Cosine is the x over r. And tangent theta is sine over cosine, or y over x. Cosecant is the reciprocal of sine, so it's r over y. Secant, r over x, and cotangent, x over y. Okay, so those are relationships that you need to understand. Basically, that is opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Same relationship, you just have to know how they work out on here. Okay, so number 1 says, point P is at 9, negative 12, so that is a point on the terminal side of theta in standard form. Find the exact value of the trigonometric functions. So I'm going to draw myself a little picture here. There's a little x and y axis. So this point, 9, negative 12, so 9 and negative 12 would be down here somewhere. And this right here would be radius. This is where my little triangle comes from. I'm in the 4th quadrant. So this length is 9, this length is 12. Yes, it's 9, negative 12, but the length of that triangle, that part of the triangle, is a positive 12. And then this is the radius that I'm looking for. So even if it didn't tell me how to find it in that first little thing, clearly we should understand the Pythagorean theorem here. So this will be 9 squared plus 12 squared equals r squared. 81 plus 144 equals r squared. So r squared is 225, and r is equal to 15. So the pieces that I need to come up with all of these ratios, I need x, which is 9. Y is negative 12, even though we used a positive there because it's the length. And then that r that we just found is 15. Sine of theta is y over r, so that is negative 12 over 15. And that reduces to negative 4/5. Cosine of theta is x over y, x over r, so that is 9 over 15, which reduces to 3/5. Tangent of theta is y over x, so that's negative 12 over 9, and that is going to reduce to -4/3. Okay. Cosecant is r over y. So technically that's 15 over that -12, but cosecant is also the reciprocal of sine, so I can just take the reciprocal of the reduced, and I get -5/4. Secant is the reciprocal of cosine, so that gives me 5/3. And cotangent is the reciprocal of tangent, so it's -3/4. So although we're just taking reciprocals, we need to know how to find them individually also as far as r over y and r over x and whatnot. All right, so let's look at the next one. It says we've got this point, -6 and -2 on the terminal side of theta. So here's my point at -6 and -2 over here somewhere. So when I draw my triangle, that's what I get. There's my little theta here. And this is -6, the length is 6. This is -2, the length is 2. And this is r. So that means that I'm going to get 2 squared plus 6 squared equals r squared. So this is 4 plus 36 equals r squared. R squared equals 40. So r equals 2 square root of 10. The pieces that I need x, which is -6, y, which is -2, and r, which is 2 square root of 10. So sine of theta, we know, is y over r, so that's -2 over 2 square root of 10. So the 2's cancel out, so I end up with -1 over the square root of 10, so that's negative square root of 10 over 10. Cosine of theta is x over r, so it's going to be -6 over 2 square root of 10. 2 goes into 2 once, into 6 3 times, so I get -3 over the square root of 10, so that's -3 square root of 10 over 10. Tangent of theta is going to be y over x, so that's -2 over -6, which is a positive 1/3. Secant is r over y, but it's also the reciprocal of sine. I could take this one, take the reciprocal, and then simplify, but taking the reciprocal here would be much better. Just gives me negative square root of 10. Secant of theta is this reciprocal, so I'd negative square root of 10 over 3. And here, reciprocal of 1/3 is just 3. Okay. On the back. So let's talk about the signs of the trig functions. Because when we start to use the reference angles, it's important that we understand not only what's going on in each quadrant, but what the signs are, and it's going to reduce the amount of things that you have to actually remember and have down correctly. So when we look down here, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Okay, you've known that for a long, long time. The other thing that you've known for a long, long time is that in quadrant 1, it's positive, positive. Quadrant 3 is negative, and quadrant 4 is positive, negative. Okay. So it says, depending on the location of the terminal side of the angle, trigonometric functions can be positive or negative. Using your knowledge of the trigonometric function values, identify the functions that are positive in each quadrant. All right. So if I think about how we're supposed to write these here that we got yesterday on the unit circle, we had cosine theta, sine theta. Right? That was our x, y there. And we also know that tangent theta is equal to sine theta over cosine theta. So in the first quadrant here, if everything's positive and positive, right? So cosine values are all positive, sine values are all positive, which means when I put sine over cosine to get tangent, that's all positive. So all of them are positive in the first quadrant. In the second quadrant, cosine values are negative because the cosine is your x value. Cosine is negative. Sine is positive. Then tangent is sine over cosine, which means tangent would have to be negative. So of those three, the only one that's positive is sine. So in the second quadrant, we have sine, which means that its reciprocal, which is cosecant, is positive. Quadrant 3, cosine is negative, sine is negative. Then when I put sine over cosine, I get tangent. Negative over negative is positive. So tangent is positive in quadrant 3, which means cotangent is also positive. Quadrant 4, so my cosine is positive in quadrant 4, which means that the secant is positive as well. Okay, so there's a little acronym, let's say an acronym, I guess it's a thing that helps you remember the signage here, and it is all students take calculus, right? Because all students take calculus. This is it right here. All students take calculus. Right? That's how you remember what the signs are. This is what is positive. All of them are positive. Sine and its reciprocal, tangent and its reciprocal, cosine and its reciprocal. Quadrant 1, all of the sine functions are positive. In quadrant 2, it's sine and cosecant. In quadrant 3, it's tangent, cotangent. In quadrant 4, it's cosine and secant. Those are the ones that are positive. Okay. Let's think about what this says here. It says if cosine theta is greater than 0, so that means cosine is positive, and it says in which quadrants, could be more than one, could the terminal side of theta lie in? Well, basically it's asking you when is cosine positive. Well, they're all positive in quadrant 1. And then cosine is negative here. Cosine is also positive in quadrant 4. So it says if tangent theta is less than 1, so if tangent is negative, which quadrant or quadrants could the terminal side of theta lie? So if tangent is negative, well, they're all positive here, and tangent's positive here. So these are the two quadrants where tangent would be negative. That would be quadrant 2 and 4. So then it says secant, if secant is less than 0, so if secant is negative, so your secant of theta is 1 over cosine theta. You're thinking about cosine. Secant theta is negative. Which quadrants would it be? They're all positive here. Cosine is positive here, so cosine and secant are negative in 2 and 3. Okay. So sine theta less than 0 and cotangent theta greater than 0, which quadrants could it lie in? So let's just look at sine first. So it's basically saying if sine is negative. So if sine is less than 0 or if sine is negative, they're all positive here, sine is positive here. So sine is negative in 3 and 4. But then I have to add to that cotangent theta is greater than 0, which means tangent is positive. Well, of these two, the only one where tangent is positive is quadrant 3. All right, next section. Use the given information to find the exact values of the 5 remaining trigonometric functions. Okay, so we're going to start with number 8. So we have cotangent of theta. So cotangent of theta is -4, which means that tangent theta is -1/4 because that's the reciprocal of it. So it's fine to think in terms of sine, cosine, and tangent so that you can wrap your mind around, what's really happening with these. And secant theta is greater than 0, which means basically that cosine theta is greater than 0. Okay, so here's our little reminder again. This is all students take calculus. So I know tangent is negative, right? So if tangent is negative, I'm looking at, this is positive. It would have to be one of these two quadrants, right? And then in addition to that, cosine theta has to be greater than 0. So that means cosine has to be positive. Well, this is the one where cosine is positive and tangent's negative. So we're in quadrant 4. Something we have to be able to identify to know what we're doing here. So I'm in quadrant 4 because tangent could be negative in either one of these. I got to know where so I can answer these questions correctly. I'm going to draw myself a little picture so that I know I'm in quadrant 4. Right? I know what theta is at this point, and that's okay. I'm going to draw my little triangle. So tangent is opposite over adjacent. So this would be my theta. So this is opposite over adjacent. And remember, even though this is negative, those lengths there are positive. And I need to figure out what the radius is. So I'm going to do 1 squared plus 4 squared equals r squared. 1 plus 16 equals r squared. R squared equals 17. R equals the square root of 17. So I have my x value here. This is a positive x. This is a negative y. And then r is positive, of course. So as a little reminder here of what we're trying to do, sine theta is always y over r. Cosine is x over r. Tangent is y over x. Cosecant is the reciprocal of sine, so it's r over y. And secant is the reciprocal of cosine, so it is r over x. Okay, we set those little ratios. So y over r is going to give me negative 1 over the square root of 17, which means I get negative square root of 17 over 17. X over r is going to give me 4 over the square root of 17. So that'll give me 4 square root of 17 over 17. Then tangent of theta is going to be y over x. So that's just going to be negative 1/4. R over y is also just the reciprocal of sine. So r over y, if I just take r, which is square root of 17, and put it over y, that's the reciprocal here. That's just the negative square root of 17. And then secant theta is r over x. So that's the square root of 17 over 4. And that's that answer. Okay. All right, let's look at number 9. Cosecant theta. So if I wanted to think in terms of sine, cosine, and tangent, cosecant is reciprocal of sine. So sine of theta is going to be negative 2 over the square root of 5. And I don't need to rationalize this. That's not like a final answer. That just gets me in thinking about sine. If that was a final answer, I definitely want to rationalize, and it'll have to be rationalized over here. But I can leave that as that. So I'm thinking about sine. So I need sine to be negative. So here's a little reminder of, all. So I have sine of theta is negative. They're both positive here, so it would have to be one of these two. And then cosine is also negative, so it would have to be this one here, and I'm in quadrant 3. Okay. Draw my little picture of my triangle here in quadrant 3. That means this is opposite over hypotenuse, so the opposite is 2. Oh, that's quadrant 2, dang it. The wrong quadrant. And I caught myself because I knew one of them had to be negative, and the radius can't be. It'll help if I'm in the right quadrant. Here we go. That's actually quadrant 3. It's making stuff up. So negative 2, so the length is 2, and that is even the opposite. Good Lord. Okay. Here's my angle. Opposite is 2. That's where my 2 goes. And then square root of 5. Okay, so it's y r, and so I have to discuss. I knew I'd get it eventually. So now I do my Pythagorean theorem. X squared plus 2 squared equals the square root of 5 squared. X squared plus 4 equals 5. X squared equals 1, so x equals 1. So what I have then is that x equals 1, and that's actually a negative 1 to get me right there. And then y equals, because technically this is plus or minus, right, when I take the square root of both sides. So y is negative 2, because my y value is negative there. And then r is equal to the square root of 5. So make sure these make sense, not just straight from here or here, but you have to think about what quadrant you're in and what's happening with your quadrants. All right, so sine of theta is y over r, so it's negative 2 over the square root of 5. So it's going to give me negative 2 square root of 5 over 5. Cosine theta is x over r, so that's negative 1 over the square root of 5. That's negative square root of 5 over 5. Tangent theta, y over x, so that's negative 2 over negative 1, which is 2. And secant theta is the reciprocal of cosine, so that would be negative square root of 5, or square root of 5 over negative 1, which is just negative square root of 5. And then cotangent is a reciprocal of tangent, so the reciprocal of 2 is 1/2. Okay, so now I need you to pause the video and grab your homework, and then once you have your homework, you can push play again. All right, so look on the back of your homework. I will work a couple of these with you to tell you how you need to be thinking through them, and I'm also going to have you eliminate some and make sure you know how you should be thinking about these. So on the back, it says, use reference angles and trigonometric function values for angles in special right triangles to find each trigonometric value. So basically, you're using your unit circle here in that thought, but I want you thinking in radians. Like, I want your brain to start just thinking 100% in radians. So we're going to eliminate the degree questions, but I don't want you to just we're just kind of mark through them. That way you still have this space here in case you need to work through it, plus I'm going to have you draw some things in there. So we're just going to eliminate these questions here. Now, I realize that you have your unit circle that you can refer to. I want you to be referring to that, but I also want you to try to start thinking without having to stare at it. Always use it to double check yourself maybe, but try not to just look at it and pull the answers right off of it, things like that. So we want to be able to think about the first quadrant. So that's what we're going to draw in here, where like number 7 was. This has nothing to do with number 7, but instead of me drawing it up there at the top. So if I just think about the first quadrant, something like that. And in that first quadrant, so this would be 0, this would be 90, right? Halfway through would be 45, which is really pi fourths. Right about here would be 30, which is really pi sixths. And right about here would be 60, which is really pi thirds. 0 is 0. 90 is really pi halves. So I kind of have those key pieces there. And this order pair here would be 1, 0. Then this order pair here is 0, 1. And then remember, these all have something over 2. The x values are 1 over 2. Then we have 2 over 2, but it's a square root of 2 over 2. And then this one, square root of 3 over 2. And then your y values is square root of 3 over 2, square root of 2 over 2, 1 over 2. Okay. Even though I know you have, and it's prettier on your unit circle, if you can picture that and think about that in your mind, or be able to jot it down if you need to, without having to look at a unit circle, that would be good. This is 0. This is pi halves. This is pi sixths, pi fourths, pi thirds. Okay, so this is kind of the key to everything. Even though you've just written it down on your paper, try and do some things without necessarily looking at it. Like try and start picturing it in your head so you can really get that down and understand how the pieces work. So let's look at number 9. So we want the cosecant of pi over 6. Okay, let's think about a couple of things that we know, things you might want to jot down as you do the problems. So cosecant is a reciprocal one, so that would be 1 over sine theta. Okay, so that you can think about sine theta in your mind. I want you to think about 7 pi sixths and where that would be. So if I think about my little unit circle here, 7 pi sixths. So remember, if I think in terms of sixths, it's hard for me to say. 6 pi over 6 pi, that'll be right here. And you go another pi sixths, so you're right here. So 6 pi over 6 is right here at pi, and then 7 pi over 6. So your reference angle then is pi sixths. The reference angle is what you need to be thinking about. You also need to think about what quadrant you would be in. You would be in the 3rd quadrant. And then in the 3rd quadrant, you have to think, is sine positive or negative? So remember that you have all students take calculus. So in quadrant 3, because I'm in quadrant 3 right here, tangent is the only positive, tangent and cotangent, so sine is negative. Okay, so all kind of things you have to process through about so that you can get correct. So then pi sixths. Pi sixths is right here. The sine value is 1/2, right? So if I find what I'm really looking for is what the cosecant of pi sixths is, keeping in mind a few things. That I'm in the 3rd quadrant, my answer is negative, even though all of these are positive, it's really 1 over sine. Well, if the sine of pi sixths is 1/2, the reciprocal of that is 2, and it's negative, so my answer is -2. So let's look at number 10. Number 10, the tangent, so I don't have to worry about a reciprocal, I can think about tangent. 5 pi fourths. So if it's a negative angle, I'm starting here and I'm going clockwise. So 5 pi fourths. Well, 4 pi fourths would get me here to pi. 5 pi fourths gets me a little bit more. So I'm in quadrant 2. In quadrant 2, sine and cosecant are positive, so that means this is also negative, not necessarily because it's negative. And my reference angle here then would be pi fourths. Okay, so I can think about finding the tangent of pi fourths, figure out what that is, knowing that my answer is going to be a negative version of that. So tangent is sine over cosine. Well, pi fourths, sine and cosine are the same thing. So you get square root of 2 over 2 over the square root of 2 over 2. That all reduces out to give me 1. This is supposed to be negative, so my answer is -1. So the second part of this, like on number 13, the directions kind of change, but really it's the same thing. And I want you processing through that. The more you can process through that, those thoughts, and think about the reference angle, you need to think about what quadrant you're in, whether it's positive or negative, all that sort of stuff. Use the unit circle to refer to if you need to, but if all you're doing is staring at it and pulling answers off, you're not helping yourself and you're not going to learn it. So it's there for you to kind of double check yourself, but try and process through those things on your own. So down on the second half here, you can mark out the ones with degrees as well. You might want to leave this space available in case you need it for scratch work or to draw yourself some pictures. So basically you're doing 19 through 24 here the same way I did 9 and 10, and you're also going to do 11 and 12. Okay, so go ahead and take your notes and glue or tape them in now, and you can get a lot of this assignment complete if you get started right away.